Hey everyone, welcome to The Explainer. Today we're diving into something most of us hope we never ever have to deal with, but absolutely all of us need to understand: a flooded home. Now, when you picture water damage, you probably just see a giant mess, right? A mop, a bucket, maybe dragging out a few shop vacs. Well, actually, scratch that. What we're really looking at here is a high-stakes ticking clock. It's a scenario that demands precise building science, rapid emergency logistics, and honestly, a deep understanding of applied physics just to prevent a bad day from turning into a total structural loss. So we're going to break down the exact anatomy of a water disaster using real-world data and case studies. Okay, let's jump right into this. 60. That is the number of minutes you have. When water invades a home, the immediate stakes are incredibly high, and every single minute counts. The industry standard for emergency response is a strict 60-minute window. If professional extractors aren't at your door, assessing the source and staging their equipment within that very first hour, permanent damage is already setting in. You aren't just sitting around waiting for help. Your home's structural integrity is actively degrading by the minute.
50 square feet. That's exactly how far water can spread horizontally through carpet and drywall in just a single hour. Think about that for a second. In the time it takes you to sit down and watch one episode of television, water has migrated across an entire living room. It's soaking subfloors, it's wicking up into baseboards, and it's finding its way deep into your wall cavities. The threat isn't just a puddle on the floor, it's a rapidly expanding footprint.
So what happens if you miss those early windows? 48 hours, that is the absolute hard deadline before mold colonies establish themselves in damp materials. This sets up the ultimate ticking clock challenge for any restoration team. Waiting just 24 extra hours to make a phone call can literally turn a basic $3,000 extraction job into a massive $15,000 gut and rebuild nightmare. You're no longer just fighting water at that point. You are literally racing against biology. Section 1. Bexley's Unique Vulnerabilities, a Geographic Microstudy. Because water damage doesn't just happen in a vacuum, local geography actually dictates exactly how a disaster unfolds. Take Bexley, Ohio, for example, which sits right in the Scioto River floodplain. You've got the Alum Creek watershed, overwhelming storm sewers during heavy spring rains, dumping 2 inches an hour. Then you've got Columbus clay soil that expands when it gets wet, pushing against foundations until the hydrostatic pressure literally forces water through microscopic cracks. Add in brutal winter freeze-thaw cycles, cracking pipes, and, in older historic neighborhoods, you have aging cast-iron sewer lines that leak, plus beautiful old slate roofs that are super prone to winter ice dams, which basically force meltwater right down into your wall cavities. It's basically a perfect storm of environmental and infrastructure triggers. Which brings us to the architecture itself. If a pipe bursts in a 1930s Tudor home on Drexel Avenue, the restoration team absolutely cannot treat it the same way they would a 1990s ranch house. A historic Tudor has plaster walls, and those hold moisture way longer than modern drywall. It probably has hardwood floors sitting over a crawl space, which requires a completely different airflow setup compared to, say, carpet resting on a modern concrete slab. The professionals actually have to adapt their entire drying strategy based on the specific historical construction of the home. Moving on to Section 2, categorizing the threat. The 3 levels of water. So the exact source of the water dictates everything that happens next. The industry relies on really strict protocols, specifically the IICRC-certified standard. You can't just guess, you literally have to test and classify. Category 1 is clean water, say a frozen pipe burst inside your wall. Because that water is clean, professionals can often just dry the materials right in place. Category 2 is gray water, like a washing machine overflow that has detergents in it. That requires active antimicrobial treatment. But Category 3, that is black water. We're talking raw sewage backups from overwhelmed street drains or storm flooding. If you're dealing with a Category 3 disaster, the entire playbook changes. All porous materials, the drywall, the insulation, the carpets, must be physically torn out and thrown away. There is absolutely no drying a Category 3 carpet. It's gotta go. Section 3. The science of drying, gaining control. This is where we shift from the sheer panic of the emergency into calculated, hidden physics. We aren't just plugging in a few fans and hoping for the best. We are utilizing psychrometry. It's a seriously fascinating concept. Psychrometry is the actual science of how air and moisture interact, and professional restoration technicians spend weeks training on this stuff. They measure temperature, humidity, and material moisture contents to calculate vapor pressure gradients. They are literally manipulating the atmosphere inside your living room to pull water vapor out of wet materials and into the air where they can capture it. And to pull that off, they track a crucial metric called grain depression. This is the difference between the moisture in the air and the moisture locked inside your walls. You see, a place like Ohio can easily hit 80% humidity in the middle of summer. If the air inside your house is already totally full of water, your wet walls are never going to dry. Professionals have to mathematically maintain optimal grain depression to force evaporation no matter what the weather is doing outside. To achieve this, they have to bring in massive industrial power. We're talking huge truck-mounted extraction units that can suck 200 gallons of water per hour out of a flooded basement. That is pure, heavy-duty mechanical removal. Then they deploy commercial dehumidifiers capable of pulling 150 pints of water right out of the air every single day. They create high-speed airflow across wet surfaces at like 3,000 cubic feet per minute just to force that moisture out of the wood and straight into those dehumidifiers. But how do they know when they're actually done? Well, they don't guess. They don't just pat the carpet and say, yeah, looks good enough. They are aiming for an equilibrium moisture content of 12 to 15% for the wood framing. They take daily psychrometric measurements using pin type and non-invasive meters. Their equipment runs 24/7 with remote monitoring, and they absolutely do not pack up until the science proves the structure has hit that exact 12 to 15% goal. All right, section 4, the path to recovery, a coordinated response. So how do we actually take this chaotic disaster and bring it back to a pre-loss condition in a logical way? It follows a rigid 4-step sequence. First up is the emergency assessment. Second is a heavy extraction. Third is the absolutely crucial structural drying phase, which usually takes around 3 to 7 days depending on how deep the saturation goes. And finally, reconstruction, where everything is rebuilt to match historical crown molding and paint finishes. The golden rule here, you cannot skip steps. If you try to rush that 3 to 7 day drying timeline, you are basically building a wall directly over damp wood, and that leads straight to hidden mold and massive, messy insurance disputes down the road. Now, during that first assessment step, they aren't just looking down at the floor. Water wicks vertically up through drywall at a rate of about 1 inch per hour. It hides inside your wall cavities and sneaks right under kitchen cabinets. Restoration experts use thermal imaging cameras to see the temperature differences where water is lurking, places completely invisible to the naked eye. That way, absolutely nothing gets missed. Let's quickly summarize the stakes across a timeline of delay. At hour 1, the water is spreading horizontally, fast. By hour 24, secondary damage begins. Your hardwood floors start to cup and drywall actually begins to lose its structural integrity. At hour 48, biology takes over, and those mold colonies establish themselves. By days 3 through 7, if you haven't fixed the problem, you're looking at a full-scale structural replacement instead of just structural drying. The longer you wait, the steeper that curve of destruction gets. Which brings us to a final, really critical thought. We've looked at the science, we've seen the physics of psychrometry, those 200-gallon extractors, the strict 48-hour mold deadlines, and even the geographical vulnerabilities that could literally be sitting right under your foundation. So I'll leave you with this. If a pipe burst in your wall right now, is your home prepared for the next 60 minutes? Because as we've learned today, the clock is already ticking. Thanks so much for joining me on this explainer, and keep learning.